So hello, welcome. My name is John Alquist. I'm a professor here at the School of Global Policy and Strategy at UC San Diego. I'm also the director of the Pacific Leadership Fellows Program, and I'm extremely glad to welcome you both in person and for those of you here online. Let me just give you a little bit of background about the center and the program, and then I will introduce our speakers and we'll move the program right along. So founded in 2006 and just renamed or amended last year to be the Peter F. Cowie Center on Global Transformation. The center fosters sustainable economic growth in countries in the Pacific region by bringing together the worlds of academic inquiry and policy analysis. The Pacific Leadership Fellows Program has welcomed well over 100 guests to the San Diego region. From at least 24 countries who consist of dynamic thought leaders from business, policy, and academic communities around the globe. The Center on Global Transformation also supports a wide range of activities central to the mission, including exciting work of the flagship research centers of the School of Global Policy and Strategy, including the Big Pixel Initiative, the Japan Forum for Innovation and Technology, and the Center for Commerce and Diplomacy, among others. So I would also like to make sure to highlight that the center funds a variety of different research programs and projects around campus, and none of these activities would be possible without the continuing generosity and support of the center's founding supporters, Joan and Erwin Jacobs. So we'd like to thank and acknowledge them as well. So today we are excited to welcome Maurizio Vecchione as the latest Pacific Leadership Fellow. Maurizio's career spans over 30 years at the forefront of climate tech, global and public health, focusing on innovation to improve the lives of the world's most vulnerable people. He's an advocate for climate and health innovation, health equity, an impact fund leader, and a global transformation architect. He is the Chief Innovation Officer at the Terasaki Institute for Biomedical Innovation, a nonprofit where he assists on strategy for translation of breakthrough technologies in the life sciences and biomedicine for planetary health and human health. Maurizio is also jointly appointed at the nonprofit Washington Global Health Alliance, an alliance that federates the leading organizations working to achieve global health equity. He's the president of Open Water, an early stage company pioneering new modalities for stroke care and prevention, as well as neuroscience and neurodegenerative disease. He's an investor in life sciences and advises multiple venture and private equity funds around impact investing, including as a partner at Ethos Capital and at Adastral Funds. Maurizio serves on the board of the UCLA Ronald Reagan Medical Health Center, the University of Washington Department of Global Health, and the Italian Scientists and Scholars of North America Foundation, and at the ReefQuest Foundation. So we're very much looking forward to his presentation. That's quite a series of activities. Our moderator for the evening will be Professor Joshua Graf-Zivan. He is the Pacific Economic Cooperation Chair in International Economic Relations, as well as the Director of the Center on Global Transformation. So he'll be managing the Q&A after Maurizio's talk. Finally, our co-sponsors for this evening are UCSD Global Health Institute and the Global Forum at the International House. And so before Maurizio comes up, we have a brief introduction to the Global Forum Fellow from Calvin Manahan.
Hello, everyone. Good afternoon. Thank you so much for joining us. My name is Calvin. I'm currently serving as this year's Global Forum Fellow. If this is your first time with us, Global Forum is an educational program by UC San Diego International House, which aims at increasing the global awareness of the UC San Diego community by inviting knowledgeable individuals to speak on globally pressing topics, such as this one. I just wanted to give a quick mention to our event for next week, which is it's entitled Climate Justice, the Global South. It focuses on the idea of how climate change affects communities in the Global South. So if you're interested, it's at this same venue, this same time next Wednesday. And so we will be displaying a survey, feedback survey at the end of our presentation. So if you could fill that out, we'd greatly appreciate it so that we can continue to put on these sorts of events. And without further ado, we will now begin. Thank you.
We'll begin the handout list of technical failures with my mic dropping off, so bear with me while I remic. It's a real pleasure to be here with you today. You know, UCSD has a special place in my heart, although I never had the privilege of attending the university, but I've been close to many of the programs throughout the university. And, you know, just observing the work that the School of Global Policy has been doing and the work at the center. Well, first of all, I'm extremely honored to be chosen as a Pacific Leadership Fellow, and the conversations I had this week with faculty and lots of other architects of this sort of global transformation work at the school has been absolutely fascinating, and I have all sort of ideas. So I'm actually very humble coming into this conversation because I don't know if there's much I can teach you about these sort of subjects that I've summarized with the headline of Moonshot Thinking. Let me make sure we're switching to the correct presentation. You know, I worked for Bill Gates for almost 10 years, and then I switched to Mac, and now I kind of lost my ability to do much on a PC, but I'll get it. Okay, here we go. Perfect. So I want to tell you sort of a personal story, which I think is at the basis of what I'd like to talk to you today. And somebody asked me, are you going to talk about alternative financing methods for transformative technologies and innovation? Are you going to talk about new moonshots and the frontiers of science and some of the technology? Are you talking about a method to normalize and use innovation as a tool for global transformation? And I went back and I said, I'm not sure. My journey in this subject started about 10 years ago, where I was called by Bill Gates. It was a meeting where, at that point, it was the 10th anniversary of the creation of the Gates Foundation. And he showed me a stack of scientific journals. And he said, this is all the covers of the most notable scientific journals that the research and innovation that I have funded has gotten me. And then he asked me, guess how many companies came out of this work that are actually out there delivering products that are saving lives? And I won't tell you the number, but it was not a large number. And the concept of how do you go about translating research and development into practical products and perhaps companies that can ultimately make a difference and solve problems, not only in the developing world, but across the world, is a really murky subject that I don't think we've created a real credible way of doing it. And for those of you that are researchers, you may say, well, isn't that what the Tech Transfer Office is supposed to do? And the Tech Transfer Office is a great place, and they do a great job. But the reality is your lab experiment that results into the publication is likely to be very far away, both in time and in funding, from being a product that is going to save a patient or drive an innovation to scale. And so how do you scale this innovation? How do you build an ecosystem is the thing that I had the fortune of using a very deep pocketbook to try to experiment with for the last 10 years. Now, we created something within the Gates ecosystem called Global Good. And it was essentially an investment fund whose subject was to accelerate that translational work. So we didn't have the ambition to be discovering new things. We had a partnering mechanism that was set in the middle between industry, that was often responsible for the scale up and the ultimate implementation, and the research community, to try to solve some of the biggest problems in the planet using this sort of translational machine. And we made lots of mistakes. So the first mistake was to think that we could take a piece of innovation in a university. We could say, this looks interesting. Maybe we have an assumption that it has certain value from an impact perspective. And we slap the title of CEO to that professor, and we give them a pile of money, and they're off to the races, and they're going to build us the great companies of tomorrow that are going to solve the problem. That never happens. Correction, it has happened occasionally. And you probably know the success stories of great academics that turn out to be great entrepreneurs, and that were able to scale up very large enterprises as a result of that. Some of your donors, our founders for the center, are in the category of people that made that transition. But it's what I call the accidental pipeline. It happens, but it happens without predictability, without systemic. So the question that we really try to answer during this journey is, can we actually define problem sets that are moonshots, because if solved, are going to really move the human condition forward, whether it be medicine, whether it be planetary health, or other subjects? Can we really use it to transform and radically move the needle around the most important problems of our time? And can we do it so that this issue of scaling becomes predictable and becomes a methodology? Now, I don't claim to have the answer to how to do that, but I spent 10 years making lots of mistakes, and I have some basic conclusion based on that experience. And we are now in the middle of a grand experiment where we're doing it again, this time not with Bill. And I'm going to tell you about that experiment, which is actually going on the West Coast, about 2 hours north of here. And I'm going to tell you about what are some of the thinking behind this so-called moonshot thinking. One basic assumption is what this headline gives you here. This has been called an irrationally exuberant opinion of the role of innovation. Is that innovation historically has been a driver for great change, not always positive, but it has been a driver for great change, which means innovation is a tool to try to solve problems that are among the most daunting problems of our time. Now, the pundits have told me, well, we tried innovation, it didn't work. And to the people that are asking me that question, I'm asking you a show of hands. How many search engines existed before Google? Do you know? Those of you with a certain amount of gray hair will remember some of the names that anybody younger will not know. But there were actually 17 attempts at getting search right, okay? And if you remember Excite, Yahoo, and then you remember of other things, they actually were the precursor to Google. So you could say, we tried search, it didn't work. Okay, so innovation can work as an engine for global transformation, but it has to be done in a certain way. Otherwise, it can go nowhere, or it can actually be a negative to the global transformation. So one of the factors is that the driving force of innovation tends to be a value system based on economic performance, and that it tends to cater to the problems of the developed world. And it tends to, Bill used to have a speech that he used to give where he said, look, at the end of the line, the great successes of the tech industry and all that has resulted in giving us a lot of toys for the rich. Now, that's a little bit of a oversimplification. You could argue that there is lots of social value to many technological evolution. Just think of the advances of medicine in the last 50 years. Just think of even the role of the internet in education and lots of other factors. But fundamentally, what's driving people to become entrepreneurs and build company is a value system based on return on investment. I talk to a lot of students, and they tell me they want to become entrepreneurs, and I say, "Why do you want to become an entrepreneur?" "Well, we want to make money." Okay, well, that's fine. There's nothing wrong with money, but if that's the sole reason for why you want to be an innovator, then I will argue you might actually be facing a challenge, because scaling a purely money-making operation is not necessarily going to be easy, and the competition is intense. So I'm going to venture to tell you that in this sort of journey with Bill, we discovered something else. We discovered that there is an equation in place. And remaining with the fact that money is important and generating sustainability for a venture in terms of profits is also important. We discovered that there was a correlation between our highest performing from a financial perspective ventures and the amount of impact, as in social impact, that those ventures were delivering. So when you talk to impact investor, when you talk to philanthropists, they'll often have a separation, and they'll think about, okay, philanthropy is about doing good, and I'm going to lose money on it. And for-profit businesses is about making money, and I'm going to make money. And there is a separation between the two. And what I'm going to argue for you is that at a time when finding great ideas that become globally scalable for profit, the presence of big problems, and if you focus on the things that can actually solve those problems by delivering high impact, is actually an operating strategy to maximize your profits. So that you don't have to think about profit and impact as two separate things. You can actually leverage the two of them to execute. And that is, I think, the most fundamental lesson that I learned in these 10 years. And to some extent, impact becomes a strategy to build the great businesses of tomorrow. Now, it doesn't require a value change, a value system change. I'm not suggesting that companies and shareholders should abandon their desire to have a return on investment. I'm simply saying that if they treat generating impact as an operating strategy, then they're going to be almost naturally selecting the projects, the products, the ventures for the kind of things that A, are going to transform the world, but B, are also going to become exceptionally successful. Now, there are a couple of factors, though, to think about if you want to implement this sort of equation. And the first one is to think about population trends. When I first started thinking about business, I had a business school teacher that told me, never invest in macroeconomics. Okay? Well, I'm going to actually tell you to invest in macroeconomics, and it's starting with population trends. I want you to understand what's happening to population trend. And these are slides from my good friend, late Hank Rosen, who created this wonderful book called Factfulness. And it's essentially identifying the fact that we as humans tend to have a myopic view of what's actually happening in the world. We're in the middle of a war. We're just coming off a pandemic. The world doesn't look like a great place at the moment. And there's a tendency to sort of have a very pessimistic view that then needs to becomes defeatist. These problems are never going away, they're getting worse, and they're accelerating. I'm going to try to show you that actually innovation has been driving some changes that on a macro perspective are key to understand what the opportunities are in this sort of impact space. So 8,000 years ago, the population of the world was maybe 10 million. So to put it in perspective, the size of a city like Bangkok or London. Almost 8,000 years later, that 10 million had grown to 250 million. The by the time you get to 1800s, we finally hit 1 billion people on the planet. And as that kept growing, it kind of stayed steady until something happened, something technological, something innovation, the Industrial Revolution. The Industrial Revolution changed the mortality and changed what it takes to survive on the planet. And so, in just 130 years, the population doubled. It got to 3 billion. And by 30 years later, it got to 3 billion. And only 14 years later, it got to 4 billion. And 13 years later after that, we're at 5 billion. That looks like an exponential, and it is. So you might start thinking, well, you know, we crossed the 6 billion mark in 1999. 12 years later, we are 7 billion. Is this going to continue? Show of hands, how many of you think this is going to continue exponentially? Population growth. How many of you think it is going to level off somehow? Good, well, you've read the book or you know the statistics. What's happening as civilization reaches a certain point, as developing countries become more developed from a child mortality perspective, the world actually starts reducing their growth. And it is widely expected that we will level off around that 11 billion people planet in the second half of this century. So 11 billion people is still a very significant growth from where we are today. And it's not exponential, but it does mean some very significant consequences for the planet. One of those consequences is, where will the people be? So each pin here is 1 billion. And you can see sort of the distribution of the population on the planet in 2015. And by 2050, these are the changes that you're going to see. And by 2100, these are the changes that you're going to see. 92% of the people on the planet will be somewhere other than the West. What do you think that means to markets and economics? Already we passed the point where the amount of wealth represented by the so-called developing world exceeds the amount of wealth of the West. Now, it's not uniformly distributed. It doesn't mean there's not a lot of poverty in some of those settings. But in terms of thinking in terms of future markets and where things are going, these population trends and the geospatial trends inherent in those mean that what you consider today to be non-markets are going to be markets, and very serious markets, perhaps even the dominant markets in the future. And that has a fundamental implication on how you want to do business planning, with a caveat that we're talking about century-long trends. So you want to be careful not to be ahead of that at that time. So some of the examples on this sort of 11 billion people planet is represented by this stack rank. The size of the square tells you where the size of the economic activity that is expected in different parts of the world. Look at China and India. The little red box, it's not that little, but the red box that when you take out Mexico, that is the United States, circa 2050, okay? What you're really seeing is obviously the China and India population contribution, but you're also seeing a certain evening out of the purchasing power and the ultimate set of activity. And by the way, this is independent of economic policy, of global development policy, of any intervention. This is just carrying forward the projections on what's happening to economic activity. You're also going to see the countries that are contributing to emissions to shift dramatically. That's not to say that the US is not an important emission contributor in any of these scenarios. I'm just saying that the US alone or Western Europe alone is not sufficient to address some of these issues. So if you're going to have any kind of global transformation using this sort of moonshot thinking, you better be thinking in terms of an international scale up, an international approach that may even be China or India centric, rather than your classic sort of places where innovation exists. And the final point is, we're going to be a bunch of old people. Old people is a definition that basically says it will be something that happens in the future. People like me are not old. But the point is we're aging. And that has a dramatic impact. Not only are we 11 billion people, not only are we shifting geographically, but we have a population that will need to access services, support, and medicine that is completely different than what we may be recognizing today. Medicine in 2050 is going to be dealing with a different set of disease than medicine today on a sort of population scale. How does all this affect poverty and this sort of evolution of these non-markets? And I want to pose a question to you. Again, a show of hands. In the last 20 years, did the proportion of population that lives in extreme poverty, did that doubled? Did that remain about the same? Or did that shrink? Show of hands for those that think that it doubled. You guys know your stuff. What about remaining about the same? What about halved? Okay, well, you have the right answer. Now, you'd be surprised to know, though, that only 7% of the people asked that question will answer it correctly. The perception is that things are getting worse. In part because we're in the middle of a war, we have the pandemic, we hear a lot of horrible headlines, but the general perception is that the rest of the world is non-markets, don't even bother trying to bring market-based solutions to the rest of the world, and poverty is getting worse, and we're essentially going the wrong direction. The reason why I wanted you to be aware of all this is because if you're going to use private sector to do moonshots that are supposed to solve the world's most daunting problem, you have to have the assumption that the world, including the settings where those problems exist, the world has to have the ability to behave like a rational market. And the answer is it does. By the way, this is actually the data for extreme poverty over the last few decades. Okay. So why isn't the world investing in innovation to drive, or is the world investing in innovation to drive solutions to these kind of problems? And we have discovered there is a real serious innovation gap. So according to this particular survey, about $600 billion a year I spent on innovation, dominated by sectors like information technology and telecommunications and medicine. And you may want to ask, okay, how much of that is going for the kind of moonshot problem solving that are represented by the UN development goals, the SDGs, of which now we are, a few years into. So we are actually supposed to be seeing, I remember when the SDGs were launched, Ban Ki-moon at the time said to me, we're going to need over 100 trillion of private sector investment to pull it off. Government alone can't do it. Philanthropists alone can't do it. So we need to succeed in getting the private sector. Well, here's the private sector putting up $600 billion of R&D annually, and this is just one survey. The number is probably higher. So the question is, how much of that is going to these kind of moonshots? And if I'm right in that impact equal success, financial success, and return on investment, then you would assume that that this would be money well spent. Not only is it solving a highly impactful problem, but it's also generating new businesses. Well, the answer, based on the same survey, is that. So you can't even see the share of the pie, okay? And that is being generous by allowing a lot of these projects to sort of have an impact metric that sometimes is being questioned. So we have a huge impact innovation gap. The private sector is basically not investing in the problem sets that would materialize the equation. And in part is because these are viewed as highly risky projects. So, investors are risk averse. I know the venture capitalists will tell you that they assume risk and high reward and so on. But the reality is the earlier stage across most of these moonshot areas are very risky, and it's very difficult to find private capital. Companies and industry is the same reason. Those of you in biotech that have tried to sell a new technology or a new invention to a biotech company or a pharma company, you know what the gauntlet is to try to get to it. Fundamentally, everybody wants to invest in something that is a sure thing, and a sure thing requires a lot of incubation. So one of the challenges is to really think through the model on how you think about what it's going to take to solve some of these innovation, some of these SDGs problem sets. And one of the fundamental problem is that people don't have a metric to measure impact. So, I have probably 50 business plans on my desk right now, and they all start saying our thing, our widget is going to have the highest impact. And then you ask the question, how do you define impact and how do you measure it? And there is no real answer. One of the methodologies that I've started using is this concept of the DALI. The DALI is a public health measure. It was designed to try to measure not just the impact of a health intervention on the basis of mortality, but also in terms of the reduction in life years that a person with a disease or a condition would experience because of disability associated with that. And it turns out that DALI is something that you can quantify, you can estimate, you can measure, and you can also apply it to things that are non-medical. So for example, you could apply on the human impact of climate and climate change and planetary health. So we started using, first with Gates, and now with my current project, we started building these sort of DALI-based models to essentially treat the impact as an extension of a financial statement. So if you think about maximizing return on investment, if you think about other metrics that any CEO and CFO would have to use, well, what if we had some DALI targets that also figure in that in order to drive the impact, again, as a strategy for business performance? So you get things like this. This is every disease on the planet, and it's the DALI impact of it. And it allows you, for example, to start stack ranking. What conditions should you be investing first to try to move the needle on the human condition and do a reduction of this DALI? By the way, the blue boxes here are non-communicable diseases. And so you can see the relative contribution of things like diabetes. The big box on the upper left side, that's ischemic and heart disease. So you can see that between that and stroke, you could eliminate a very significant set of disability or DALI if you could make a move in those areas. But then it becomes hard to say, okay, I understand stroke is a big thing. How am I going to know what intervention in stroke care is going to translate to the maximum amount of DALI reduction? And to do that, you have to get much more sophisticated. You have to construct statistical models. So this is an example, for example, of looking at DALI intervention for a specific disease in a specific part of the world using simulation. It happens to be Madagascar, by the way. And using this massive stochastic simulation, we can actually decide that a new diagnostic for a specific condition in Madagascar will have the highest DALI reduction of any other interventions we could make. And so being able to do that allows us to build essentially a thinking around what projects we want to invest in and we want to launch that is based on maximizing the DALI reduction. And when you start doing that thinking, you end up in 4 quadrants. You end up looking at impact on one axis and risk on the other axis. And risk is sort of a blended parameter. It incorporates this notion of how difficult it's going to be to scale up that solution, but it also means what is the cost to scale up a moonshot solution. And for the very high impact and the very high risk, that's when you're in moonshot territory. And when you are very high impact but lower risk, that's actually a good thing. That's the focal part of your investment. You also could conceivably go after things that give you lower impact, but are also lower in risk. I call that opportunistic. You know where most of those $600 billion of R&D are actually going to? They're going into that opportunistic category. A lot of evolutionary technologies rather than disruptive technologies. Okay, and the one thing you might want to avoid is the yellow box, which would be low impact and high risk. You'd be surprised how many R&D projects, including funded by our government, are in that category. So the discipline of quantitating impact and looking at essentially cherry picking the projects around moonshots that are going to be worth solving, in my opinion, is critical to be able to build a research portfolio that has that kind of impact, and more importantly, that can then directly be correlated to solving some of these big problems. And I think I'm going to pause here because we're running out of time. Josh, correct me if I'm wrong. And I hope to have teased you enough with some of these thoughts to generate some questions. What I didn't show you is the work that we're doing at the Terasaki Institute, which is an institute that has been created specifically with the objective of investing, primarily nonprofit funding, investing in this sort of approach of quantitative problem space in what we call a problem-first approach. So much innovation starts because somebody has an idea. It results in a discovery. And then you ask the question, what can I do with this? So it ends up being technologies in search of a problem. Occasionally, the problem that you can solve with those technology becomes a big, impactful winner. But often they become those low risk, low opportunity, low impact opportunities. We would like to believe that you have to go problem first. Define the problems using the kind of methodologies that I've described first so that you can tell a group of scientists, this is the challenge, this is the problem. If you solve it, we have an infinitely scalable solution that can not only lead to commercial activity and translation, but can then drive a move the needle approach to the specific problem. And I'm going to end here and take questions.
Great. So I've got a couple questions pre-populated. I'm going to start out with a hardball question from me to put you in the hot seat while you're being recorded. You said a lot of things about translation. As you know, NIH and NSF have a bee in their bonnet about translation also. Mm-hmm. Many universities, including this one, are investing in translation science units of some sort or another. And what I hear you saying, particularly on this last slide, is that those translations often are science in search of a problem. So should we be thinking, instead of translation science units, in terms of, I don't know, backwards induction science units or something? So tell me what they've got wrong, or what's missing in the ingredient that these guys are pushing on.
So first of all, I don't in any way want to criticize the very good work that lots of people in translational sciences are doing, okay? So this is not black and white. So I'm going to use generalization that will not apply to many examples. But in general, I find that very few researchers have an understanding of the problem they're actually trying to solve from a human condition or a target. Now, they may be working in cancer research and they have a general desire to advance cancer research, but then it gets very rapidly pretty tunneled and pretty specialized. And when NIH talks about translation, and I actually spoke with the NIH extensively about some of this, they're often very tactical. So there is a compound you've discovered, or there is a mechanism of action you've discovered, and you now need to make sure you go through the gauntlet of regulatory and other approvals so it can actually get to patients. And that's important, but it's kind of tactical. If you really want to step back for a second and say, where should we prioritize our research and development effort, and ultimately, what stakeholders should come into what is essentially a collaborative ecosystem? Because translation, almost by definition, is interdisciplinary. And, you know, the wonderful academic lab that has made the discovery is very unlikely to have access to the engineering and product development resources and everything else that often is done not just by one company, but by multiple companies and possibly multiple collaborators. I had a technology within Global Good that was a new material science technology. It was essentially the discovery and ultimately the exploitation of something called metamaterials. Now, the irony is metamaterials were invented by a UCSD professor who then went on to be at Duke. Let's forgive him for that. And so the science, the discovery was done, but the practical translation into something that would also be a product had escaped everybody. And so it was an obscure academic research field. What it took was somebody out of liquid crystal displays, an engineer with experience working in Korea, to actually realize that the thing that would make the metamaterial a practical application had been done in liquid crystals, and you could duplicate that. And ultimately, we created a metamaterial sciences center that ended up spinning out 7 companies, exploiting that sort of engineering work that needed to complement the scientific work. That is rarely done with the type of either university or NIH, because it's so interdisciplinary that you don't know going into it what resources you're going to need to do. So I don't know if that's an answer.
Yeah, that's great. So let me start out with one from online, and then we'll go around the room, and I can pull more from online if need be. So we've got a question from Sean here. He asks, and you didn't really touch much on this on your talk, but I know you've worked a lot on this, so I'm gonna throw it at you anyway. So he says health equity is good for all. We recognize that health equity is important, and yet disparities are prevalent. Mm-hmm. How do we think about, he doesn't quite frame it this way, but how do we think about innovation in this space to resolve that particular issue?
Yeah. So, by the way, that is an SDG, not expressed exactly in those words, but it has been recognized at the UN level that better health is not just a question of technology and medicine, it's a question of health delivery, right? And if you've sort of analyzed what happened in this pandemic, and this is true everywhere, not just in the US. So it transcends a national health system, it transcends poor versus rich countries, it transcends our system. You know, the impacts of the pandemic overwhelmingly affected certain populations. And you can see it in the mortality figures. You can see it in who got the disease. We haven't even begun to analyze the details of it. And when you talk about innovation, you tend to immediately jump to technology. But much innovation is actually about things like health delivery, health system transformation. So one trend, for example, is the democratization of health access. Right now you think about medical tests, you think about going to a lab, or maybe a physician or a specialist. I was on a panel for the National Health Service in the UK, and we analyzed the delivery of healthcare in a national health system, only to discover that 70% of the patients in British hospitals would be better off clinically to be out of the hospital. Okay, but we are conditioned, and the system is pushing people into specialized care that is also expensive care. And at the same time, we're not exploring the fact that those patients could have access to the care they need well outside of those confines. And all that, by the way, evolving the healthcare system is innovation. Okay, so the answer to the health equity question, which is absolutely fundamental, I would even go to the point that if we don't succeed in providing the right care to all, we are not going to be advancing medical care and ultimately outcomes. Another data that I'm fond of representing, I live in Los Angeles, and the western part of Los Angeles, called West Los Angeles, is an affluent set of neighborhoods, has more MRI machines than all of Western Europe combined. Okay, and you would say, okay, so is Western Europe, is the West Los Angelenos on average much healthier than the average West European? Quite the contrary. So if you look at our health outcomes as a system, we definitely have the most expensive system. We have a very inequitable system, not just because of availability of insurance and all that, but at the same time, we don't even have the right outcomes. So health innovation, in my opinion, is not just new drugs and new treatment and new diagnostic and new technologies, but it's new delivery system. One trend that I'm very fond is the fact that much health technology sits right here. And it won't be long before this is your primary care doctor. And the diagnostic capabilities that used to require a big iron machine in some central imaging lab in a hospital very soon will be wearable technologies that everyone can have. I am involved with a company called Open Water, for example, that is building an MRI machine in your phone under AI control that can do critical diagnosis for you as an automated process with a wearable device. And you could technically do it at home. That's the kind of disruption that can radically change the healthcare model. So I'm optimistic that we're going to achieve that, but it's going to take a rethinking of the systems, a rethinking of the technologies that enable those systems, and it's going to require tight collaboration between the innovators and those that do healthcare delivery on that question specifically.
Great. I have like 100 follow-up questions, but I'm going to give someone else a turn. David, someone should bring you a mic. Yeah.
So thank you very much. It's really terrific, in particular to see the shift in thinking about the portfolio of moonshots. I'm curious about the area where you have personally the least experience, which is government. What's the role of government in all this? It seems like you're a little critical of, more than a little bit critical of NIH and the way it's done translation, and the same would apply to every other arm of the government. Do we shut down the government? Do we reform the government in some way that it can play a more constructive role? What's your thinking about that?
So if you look at this concept of risk and impact, there is a time when you have such level of high risk, even if you are normalizing for high impact, where it's completely unfeasible for anything other than the government to be supporting that work. You could argue that's the pure academic research stage. Maybe it's even a little bit later than that. Just suppose that with the tail end of that translational cycle, you can't even be really a sponsor at the FDA if you're not a company. Okay, so at some point on the tail end of this process, the risk-reward equation becomes feasible for purely commercial endeavors. And then you have all the thing in the middle. And all the thing in the middle are a blend of government, especially with some of these programs that are driving more translational applications. You know, it used to be, when I started with NIH work, you know, making money on an innovation was considered a dirty word. And you know, and the government didn't want to be an enabler of private sector activity. To this day, many universities will tell you that we don't want our faculty to be building companies. The tech transfer office will spin things out, but our faculty has to stay committed to the public good and the development. And there are countless cases of academic entrepreneurs unable to continue their academic work because they had built a company somewhere on the side. That sort of equation is wrong, and I think there is an appropriate funding mechanism for each one of these stages. So I think government is on the high risk side, philanthropy is on the middle risk side, and then as things graduate past that, then you have private investors. And at that point, you have essentially mitigated the risk. There's still plenty of risk, but you've mitigated the risk so that the private investor can make a risk-reward decision and commit to a moonshot. But it's a moonshot that is slightly de-risked by the fact that government money and philanthropy money has gone into it ahead of time. And I at my institute, at Terasaki Institute, we're actually practicing that. We have, you know, a very healthy pipeline of NIH funding. We then have, we match that or follow that up with our own foundation that has essentially nonprofit funding. And at the end, those are precursor capital to investor capital that then builds companies and launches them for scale up. Scale up is always the job, I think, of the private sector. They know how to do that really well. High risk at the very beginning is difficult for investors to rationalize.
Other questions? Chip, go ahead.
So you talked a lot about the daily concept is a great way to look at allocation of resources for discovery. But when you actually get to the consumer end of things in the healthcare system in the US, we don't use it. Mm-hmm. We incent CEOs on the basis of how much their profit margin was the previous year. Mm-hmm. You could argue that, I guess, national healthcare systems incent and invest on the basis of DALYs. How can we move our needle in that direction so that we're not concentrating all the MRIs in West Hollywood? They generate a lot more money than that many pediatricians, but we don't have a way of investing in the pediatricians.
So I have a political statement, philosophical maybe first, and it's not mired in wanting to criticize the private healthcare delivery system at all. As a matter of fact, I was the product of a public healthcare system that didn't function too well. I grew up in Italy, and you know, we have a great healthcare system, but not if you need something highly elaborate. And if you need something highly elaborate, then you go to a private system in places like Switzerland or the States, if you can afford it. So I don't think it's just about the type of healthcare system that is the solution to that. And I'm going to tell you a story about a discovery we did when I was with Gates that illustrates what I'm talking about. I guess before I tell you that story, fundamentally, I think the answer is that a more cost-effective treatment that works better is always going to win over a less efficient treatment that costs more. So the example of the MRI, Sure, I have a huge uphill battle and specific market strategies to try to get the open water technology to become a standard of care in place of, your average CT or MRI machines in your average imaging center. And I'm going to be fighting a whole industry. But at the end of the line, if you're going to be a disruptor, that's what you need to do. And ultimately, you need to do it with the ability to bring it to scale. So you need to pick the right partners, the right capital sources, and all those kind of things. So there's a lot of execution challenges in trying to achieve that. The story I was going to tell you has to do with cervical cancer. That was probably the biggest success we had at Global Good. And, cervical cancer, women in the audience know that every year to prevent it, you are supposed to do a test. It's called the pap smear. And, you might not be told that the pap smear is probably one of the world's worst tests in terms of sensitivity and specificity. It's got a sensitivity and specificity on the order of 60 to 70% in a good day. So why would you do it? Well, you do it because the disease progresses slowly, and by repeating it every year, you end up ultimately catching the disease if you have the onslaught of cancer. Gates brought you the HPV vaccine. And so when in theory, at some point, everybody will be vaccinated and the disease will disappear. It's a cancer, but it's actually an infective disease. Except we calculated using the DALI methodology that between now and the time that everybody's vaccinated around the world, we would kill 25 million women if we ignored the issue of screening. Only the US, Western Europe, and a few selected advanced countries have the pap smear infrastructure. The vast majority of women around the world never do a pap smear, never have a screening, and therefore end up having 85% of the prevalence of cervical cancer and very high mortality. So we started investigating ways to change the paradigm for testing away from the pap smear. I won't give you all the details. It suffices to say that the NIH had collected back in the 80s and the 90s a film library of cervical cancer patients, pictures of the cervix, and then that longitudinal study tracking those women for 18 years with outcomes and cytology and all these kind of things. And we put machine learning on that. And it turns out that we developed an algorithm that discovered a new visual biomarker. And in a camera phone, with that algorithm, taking a simple picture of the cervix, something a nurse can do, in one visit, you have 99% predictive ability of the onslaught of cancer. It was such a good result that the NIH pushed for a change in clinical standard. And actually, in 2019, at the World Health Assembly, 111 countries adopted that as the new standard of care for cervical cancer screening. And now you have a product that is basically a piece of software in a camera phone with a little bit of training that can be put in the hands of any primary care environment, and that can essentially solve that issue. So how did it go in the US? Well, obviously there's a whole industry providing cytology services and pap smear, and most of the women in the room are probably still going to the pap smear, even though the US was one of the countries that signed the standard of care. So ironically, women in the developing world are now accessing a better test at a lower cost that can only do once, and women in advanced countries like the US are accessing a more intrusive, less effective test because of the way the healthcare system and the momentum that it takes to change the standard of care. But it is happening. As a matter of fact, I was very pleased that in West Los Angeles, a gynecological clinic was advertising the other day the new advanced artificial intelligence-based test that you can only need to do once when you're age 24, and it'll be and it's better than any other test, et cetera, et cetera. So it will happen, and I think it will happen because it's cheaper, it's better, it's faster. It just will take time. And the companies that are now involved in commercializing that have to make an adaptation. The business model is no longer build a lab and charge a high reimbursement feature. The business model is higher volume, enable primary care physicians and nursing staff to perform the test and somehow get less in reimbursement, but more. So it's an example to show you that even in a system that is reimbursement driven, you can affect that change if the product is superior, if the solution is better, if the solution fundamentally is a little lower cost, but it takes time.
Well, I'm afraid we're getting the high sign from the back of the room. The good news is we have a reception to follow right here on the patio. I'm sure Maurizio will be happy to answer more questions, but please join us outside for a little refreshment. This is one of our early in-person events, and we're delighted to actually be able to be out on the patio there for a little bit. Please join me in thanking Maurizio for this interesting talk. And let me just finally add, Maurizio is here through the rest of the week. I'm not sure he has much bandwidth left in his schedule, but if you have a burning question or you want to get on his schedule, please reach out. And if we have space, we'd be happy to accommodate. He's here with us through Friday. So thank you, and we'll see you out on the patio.